In this tutorial we'll have a look at how we lay out stereo clips on a timeline before we start aligning and working with them. Essentially there are two types of stereo clip that we're likely to encounter. One is like this, where I've got a separate file for the left eye and for the right eye. So the first thing we need to do is make them a stereo pair, and that's pretty simple. All I need to do is just align them together and add from the effects menu Stereo 3D effect. What the Stereo 3D effect does in its simplest form is to take the first input as the left eye and the second input as the right eye. So all we need to know at this stage is that the left image always goes on top of the right image. As we know from the other Mistika tutorials, rising out of each clip or effect is an image channel and an alpha channel. Well, rising out of a stereo effect or a stereo clip are two channels. There's a left eye taken from the first input and a right eye taken from the second input, and both those have their respective alpha channels, and we can see those channels if we double click on the stereo effect. And the first thing we need to ensure is that use stereo mode down here is on. That tells Mistika to process left and right channels. And then using this drop down menu here, which we'll look at in detail later, or the shortcut keys for it, we can see the two channels of images that we've got. Going back to the timeline, the other type of clip we might encounter is this, where in fact this single clip actually has a left and a right eye built in. And what tells us this is the :LR on the end. There are two ways this sort of clip might come into existence. The first is if we captured this clip from a VTR that supports dual stream playback, such as an HDCam SR deck, in which case the capture takes the left and the right eye at the same time and creates a single clip from it. The other way is we can create those single files in output by selecting under Stereo 3D mode the dual YUV422 setting. So that creates the same sort of clip that would be captured from an HDCam SR deck. We can split a combined clip into two discrete channels if we want to. So under Edit, there's Stereo Break, and you can see I've now got a :L for the left eye and a :R for the right eye. At any point, even if I only have one of them on the timeline, I can recover the stereo pair. This recover stereo only works with clips that were once upon a time captured or created as dual stream. So let's look practically at how we might start a stereo project. So I'm just going to get rid of this from my timeline, and I'm going to look in my media. And what I have already, I've gone through the import process and I've arranged into two folders, a folder full of left eye rushes and a folder full of right eye rushes. Now when we come to start a project, it might be that we're working directly from the camera rushes, for example to organize them and to align them before the editor gets them. Or it might be that we're a little further down the pipeline and the project has already been cut and we're now looking to do a stereo conform. So firstly let's look at taking in all the camera rushes on the timeline ready to align them. So what I'll do is I'll just select all these left eye rushes. So they're all now sitting on my timeline. Now in theory, to make the stereo pair of these, I would theoretically only need to load up all the right eye rushes as well and put them in a line with the left eye rushes. Unfortunately in the real world that doesn't really work. Although it would appear to work at the beginning. As you can see, we have clips that start on the right time code and are aligned with each other. If we actually go to the end of our timeline, we can see that actually something's gone wrong. They've come out of sync with each other. In fact, the last clip shows the problem perfectly. You can see that these clips don't actually start at the same point. This one starts at 5614, this one starts at 5611. For this particular shoot, although the cameras were correctly locked together, so both cameras were recording the same timecode, the cameras, just through their design, will tend to start recording at different times. So in this case, this camera, the right camera, started recording 3 frames earlier than the left camera. So that means that lining up clips purely physically to their left-hand edges obviously doesn't work. You can see we've got a mismatch. The correct lineup would actually need to be that, so that the time codes match. Another problem that would prevent this method from working as well is, of course, if there were more clips in one folder than the other, which is not uncommon, that one camera might fire and the other one doesn't. So we need a more reliable way of getting in the other eye. So I'm going to delete out the right eyes for a second. And actually the way to get a more reliable lineup, assuming of course that both cameras are recording the same timecode, is to use the conforming parts of Mistika. So with just the left eye only, I'm going to select everything and hit U to get up my edit marks, and I'm going to create an EDL from there. So under Output, Export EDL, and give it a name. And generate. So now I've got an EDL. I'm going to want these left rushes in a minute, so I'm just going to select them and Control C. So I've copied them. So now if I go to my Conform, Mistika Clips, EDL file, well, if I look in my output, I'll find the EDL I just created. There it is. So the next question in the Conform is, where does it find its real names from? Well, strictly speaking, this EDL puts its real names here. But actually, of course, if I told it to look for these real names, it would fail, because you can see that these have L's in them, whereas in fact all my right rushes have R's in them. But it won't be as simple as going into a text editor and swapping L for R, because actually these serial numbers will be different as well, because they're auto-created by the camera. So in fact I'm going to tell Mistika to ignore the real names altogether and just match by timecode. And I'm going to give it a route path to tell it where to find the rushes. So they're in here. And I'm going to hit Perform. So that's now created another environment. So I'll double click that to get it up onto the timeline. So that's now a conform of the right rushes. If I now just go Control V, remember I copied my left rushes, there's my left rushes. And now I know that the alignment will be correct based on timecode. Now if I zoom out with this conform, we'll see that every now and again we're getting some oddities in our conform. And the reason for that is that, remember, we asked Mistika to ignore the real names, because as we can see the real names are different. They're the same to a point, but there are fundamental differences in the real names that would cause the conform to fail. But of course, by leaving that wide open to only match by timecodes, it's also happened to have found other clips that match that particular timecode. Now in small conforms, it's no great hardship to see that evidently some things are just wrong. You can see that this wasn't even a complete clip, because the timecode range of that shot didn't extend along the entire length of the shot that's required. So I could easily just delete that out. But actually I might also use the conform tools to help me a little bit, because if we go back and inspect these real names, we can see that at least they're the same in this particular conform up until the L and the R, whereas the incorrect shot has come from a different take. So alternatively what I could do is, if I went back to my conform, under here I can say that actually I do want you to match the real name, but only the first 5 characters, because under here the A015 underscore is common, 5 characters. So now let's just perform that again and reload the new version and just pop back on our left rushes again. And now if we zoom out, we can see that actually we've managed to filter out those false positives. So that was starting with original camera rushes, but using the conform process to get the other eye. If we're not working from unedited rushes and we're actually doing a final conform, then the process is the same, that we take the editor's edit list and conform against the left eye and conform against the right eye. It might be that the editor has given us two lists, one for the left eye and one for the right eye, because they've already matched the two together, in which case we can conform separately and copy and paste the two streams together like this. Or it might be the editor's only cut from one of the eyes, in which case we can use the processes we've just done to conform the other eye from the list. So the remaining thing to do is to get on our stereo effect onto all of these shots, and there's a little trick for this too. If I selected my left eye rushes and hit stereo 3D, I get a stereo effect that's nicely chopped up, but as you can see it's only taking the left eye. The scope for this effect actually needs to be down here, and it'd be pretty tedious to go through all these doing this. So you might hope that you could select both and hit stereo 3D. Unfortunately it does that and puts a stereo 3D on everything, which isn't entirely helpful in this scenario. So this is the workaround. Pick your first shot, select a pair and get stereo 3D on it. So now this has got the scope right. Next thing is get the duration right. So I'm going to get the duration by selecting all of my conform, and then I'm going to set the duration, which of course both of those I could easily do with gesture controls. So now I have one stereo effect over the whole lot, but actually I will want to chop this up because the stereo effect has all our alignment and depth grading controls, so we'll want them to be personal to each shot. So ensuring that the cursor is getting down to a level that's got a load of cuts in it, all we need to do is just go to Edit, Macros and Split Conform. And what Split Conform does is it'll take all the edits that are within the range of the cursor and transfer those edits to anything else within the range. So we're almost good to start thinking about alignment and depth grading. But let's just look at a couple of issues that these particular rushes kick up. If I double click any random shot, first thing you'll notice, the sharp-eyed amongst you, is it's upside down. Now having shots that are upside down or back to front in a stereoscopic shoot is very common because of the way the cameras are mounted on rigs. Now we'll go through all the tools of the stereo effect in later tutorials, but let's just look at the top one, mirror. Mirror basically allows us to deal very quickly and simply with the problems that we have. So I'm just going to set this mode to anaglyph, so now we can see both of our channels, left and right. So let's firstly just mirror them vertically, so at least it's the right way up. But you can see that between the left and the right image, they're still horizontally flipped. Now this is where things get interesting, because with no writing in the scene, how do I know which is flipped? For example, if I turn the left eye to rotate, I've now created a shot where the left and the right eyes are in the same direction. But I could also have done it this way round. So the thing is, how do I know? Well, so long as we believe that we've got our clips the right way round, with the left and right eye left on top, then we can actually use this method. I'm just going to quickly roughly align the images. In a later tutorial we'll work out what all those are. But as you can see that when I go to the left and to the right, left, right, left, right, we get a certain amount of jumping around in the image. Now you might have come across the phrases positive and negative parallax. Positive parallax refers to any object that is further away from the camera than the point of convergence. And negative parallax refers to anything that's closer to us than the point of convergence. The point of convergence is actually where an object from the left image perfectly overlays the same object in the right image. So I just quickly match here. You can see that as I go between left and right, this particular corner of the TV isn't moving, but you can see that anything further away is jumping left and right, and anything closer to us is jumping left and right. And actually, if you look carefully, they're jumping in opposite directions. So we're looking here at the left image. If you look at this item in the distance, as I jump to the right, you can see that it's gone to the right. And I go to the left, it jumps to the left. So right image, left image, right image, left image. So it's jumping with me. On the other hand, if we look at the guy in the foreground, and we know that just from looking at the scene, he must be closer to us than this TV. We're looking at the left image at the moment, and if I jump to the right image, you can see that he's actually come to the left. So I go to the left image, he jumps to the right. I go to the right image, he jumps to the left. It's crossed over, and that's the meaning of negative parallax. There's a crossover occurring. So this actually tells me that from a stereoscopic point of view, this shot is the right way around, because I would expect that anything in the negative parallax, anything closer to me than the point of convergence, must jump in the opposite direction to how I'm looking at the image. So as I go to the left image, it goes to the right. As I go to the right image, it goes to the left. Meanwhile, anything in the distance beyond the point of convergence, as I jump to the left, it goes left. As I jump to the right, it goes right. So if I got those the wrong way round, you can see as I go to the left, watching the guy in the foreground, left, right, it's not crossing over as we'd expect him to. One thing that comes along occasionally in stereo conforms is where the editor has flipped a shot from left to right. So where the actor walked in from stage right, it's flipped so he walks in from stage left. This trips up everyone the first time they come against it on a stereo conform, because when you apply your flip to your images, of course you're also flipping the left camera to be the right camera and the right camera to be the left camera. So your stereo goes inside out. So if you do intentionally flip a shot from left to right, you actually have to reverse the order of these. So right will go on top of left. Let's just look at another problem that we might come against when we're doing some conforms. We can actually see here that our left and right images are out of sync with each other. Even though we've been careful with our conform that our left and right clips are matched by timecode, in this instance, for whatever reason, one camera has decided that it's going to record in a different position. So in this instance, we can use the shift clip functions here just to help manually resync the image. So using our display modes, well, there are a few different ones that I could think about using. Difference would be quite a good one in this instance. And if I just pick whichever clip I'm going to change the sync of, I can just nudge this a frame at a time until I get to the point where I believe that they are in sync again. So this gets us to the point where our project is conformed, or we have access to all the clips we want to work with, and we're ready to start the alignment process, which we'll look at in the next tutorial.